setting their goals.
Right, and I think the Gatlinburg fire, I think it can anchor your thing and make it, significant to the local people. But I think, bringing it broader to looking at how it evolves and different things.
Well, yeah, that can be the catalyst to make, start thinking about, because we never think about fires. We never have.
Right.
Every year is in California and out west and Colorado. We don't deal with that in these Tennessees. So now something's happened that's actually made our kids aware of. Next time they see that on the news, it's like, man, those people, they're suffering. Because it's real to them. So that could be that's the start of it. Right?
I have a question about the educational mission part of this. Just kind of an idea to float, and it gets to the process and system engineering kind of approach that you were describing. So we were kicking around the idea of having this set up sort of parallel to the way a Model UN project works in high schools and middle schools, where you have this mocked engagement of the kids in a professional, end-to-end, in this case, engineering process where there's a design requirements gathering product. And so I'm just wondering if we set it up that way, where we're going to try to, part of the educational mission would be to try to be like a full-blown NASA mission and have all pieces that
well, I think you have to, right? I mean, we go through this process because you have to do it. And so you have to have requirements, you have to have designs, you have to review them, at some level. And so I think I think thinking about that and doing it purposefully is probably really good for the students and get this educational experience.
So if you do that, what is can you suggest a process, or where can we learn about exactly how does NASA do this for its missions, or is it everybody does it differently? And not just
every
There's
project's unique, but there's there's a process we do. Kevin's good.
Yeah, that's part of what we do as system engineering, and I hate to even recommend a NASA document because sometimes they're a real slog to get through. The one that's pretty readable, I guess, is our System Engineering Handbook, 6105. And that's, if I'm looking for a NASA document, I go to Google. I don't go through the NASA system, I just Google it. But that's publicly available, I'm sure.
There's not.
It is?
It's alongside the fire.
There's the website, the Systems Engineering, NASA Systems Engineering website.
Yeah, and that can probably get you to the 6105.
But if you just Google 6105,
You'll get it.
NASA.
Yeah, great. It's NASA Handbook, I think it's actually NASA Handbook SP 6105. So if you Google it, you'll probably get to it. And even an older version is fine if the latest version is
Right.
inside the firewall. But it's the process you're looking for.
And
that
this
will,
is end-to-end from
It does.
conception to
Yes.
Yeah.
dissemination.
and it's a handbook, it's not like a lot of requirements, it's probably a little bit more accessible than some of the other documents.
There's 17 different processes that it covers,
Yeah.
that covers the whole lifetime of the system development, from the conception to the what is it, discard stage, disposal stage. And so that's in that document, they call it
Yep.
the engine.
System engineering.
And if you look at each one of those stages and how you address it.
And we have training classes on each one of those
Yeah.
processes.
So do you, as far as the educational aspect of this, do you, do you build your classes around this? Your science classes around this? Because it seems, in addition to process, there's also, there's hardware, there's the physics, there's the whatever. And Kevin and others have already mentioned today about the flat floor, the flat sat approach to doing this, and just being able to get your community, for example, because hey, we had this fire, to donate something, to donate some money for. I help kids with Lego robotics, and so I use that as a parallel here. Can you build a classroom spacecraft and test and play and experiment with various techniques for doing these things, particularly in the power areas, the electronics areas, the comm areas?
We have the ISAT,
test bed
Right.
set up, but, I mean, if you walk over to go see it. if
Well,
you-
yeah, maybe, yeah.
Yeah. So,
But I would put that in parallel with
Yes.
the process work, just to
Well,
kind
that-
of give them a
that's
flavor
interesting.
of, you
Yeah,
know.
Tracy is with the district and is thinking about this more broadly. We talked on the bus
Yeah.
of a curriculum.
So I just had a question about that, because when I think about the educational goals, obviously Robertsville Middle School is a middle school. We haven't seen a middle school launch a CubeSat, and so there's that educational component that you all were saying is kind of already checked, because we are a school and a public school and a school with a high economically disadvantaged population. We already are checking off some boxes with that. And the kids will really benefit from this. We also have a really supportive community, as y'all can see. But one of the questions that I really have, or that we've discussed, is there a curriculum component? Like, are we doing some kind of curricular design along with this? Or are we kind of going through the process of learning how to do that, and that's the educational piece? Or are we trying to develop an actual curriculum? So I'm kind of confused about what the expectation is around that, because if there's a curriculum development component, that's a whole other kind of major thing that would need to be addressed, and has its own action steps associated with it. if that
So
makes
you're
sense.
asking, does the NASA competition
Yeah,
require a curriculum?
Yeah, first, yes, and then kind of connected to what you were saying
Mhm.
too. So you have this space where the kids are going to create and work, and luckily Todd has these classes in his schedule. And as you can hear, it was kind of cute to hear the kids like, this is my second year working with NASA.
Yeah. Wow.
I'm in 8th grade. I thought that was really sweet. But so we do have, a space in the master schedule. Mr. Adams creates that space, and we have a teacher who's obviously very energized. But is there kind of a curriculum design component that is also a piece of what we're supposed to be doing? Or is the educational side satisfied through the kids working on this process without doing that piece?
Well, I don't know what the competition calls for, but I would think it would be a tremendous opportunity to take the classes you already have and try to infuse in them bits and pieces of the puzzle. Whether you design a whole curriculum around that or not, I don't think that's a requirement, or I wouldn't think would be a requirement.
I think it would strengthen that.
I think it would strengthen it,
educational check mark.
Because if they could come up and present that they've got a great idea, they've gone through the engineering process, and oh, by the way, we've tested propulsion units, or we've tested GNC units, or computer units, or whatever. Yeah, I'm sign me up.
If they put that down on their college applications, it's,
Oh, they're
to me, it's like
in.
a shoe.
Yeah.
I mean, they've gone through this whole process, because just the act of doing it forces the entire technical process of learning from start to finish, the checkout, working with groups, the bickering that's going to occur between the different groups about, hey, you just messed up what I'm supposed to do because you decided to do this,
Right.
and all that trade-off that you go through.
Well, let me ask you this. Next year, looking at this, one of the biggest problems we have is we don't have enough Todd Livesey's, and we don't have enough programs for all students to get this experience. So what we're going to do next?
What do you mean you don't have enough programs? What does that mean?
Well, he teaches his NASA students during our enrichment period.
Okay.
So you're looking at the kids that you saw today. Those are the kids, and we just can't open it up, because what happens, we have to turn away kids, because there's hundreds of kids who want to sign up
First
every
year we did this, Mr. Lay proposed we do this. Thought, well, I hope we get it done. We had 152 kids, 1/3 of the 6th, 7th, and 8th grade. So
That just makes me feel it's like there's still not many kids, still interested. Right?
That's exactly right, and see, that's what I thought this was all about from the beginning. Is NASA saying, hey, let's get back into the whole exciting kids thing. When I was a kid, that was the coolest thing in the world was built. Because I watched the moonwalks, at school. I watched all that stuff, and that's what we all want to do. Is that firemen, policemen, So, you know, I'm hoping that's what we're gonna do. We had kids walk out here, go to high school last year, I wanna work for us. And these were kids that probably will work for us.
Well, I got a question though.
Yeah, okay.
So here's my question. So next year, what we propose is we have a careers course, and we're hiring that individual with the understanding that we will have a NASA class for all students, but it's on a rotation. So you'll have the 5th and 6th first semester, 7th and 8th second semester. It won't be his class per se, but it'll be connected. They'll work together. And some of the things we discussed, they would work on the research for his kids who actually do the work. So they're the department who works on research projects possibly, and they actually put it to work. Now would that satisfy? I mean, and we're already working with NASA anyway. We have their curriculum, and they can use the curriculum if they're not working on that project. We have NASA's curriculum where they can actually use that as well. So just wouldn't that satisfy?
Well, as far as the competition is concerned,
Yes.
yeah, we're not exactly the right people to answer that question.
Okay.
But it seems like it would.
Okay.
I mean, you can say we're a school, so we check the education objective, but showing how that's really driving your curriculum and engaging your entire student body, hopefully, that would make that even stronger, because a lot of other schools are probably in competition as well.
But
So.
the pictures you showed of the schools that you talked to, where you see students in what looks like a classroom, actually working with, I don't know what forum or what setting that was in as far as, was that a required class? Was that a careers class? Was that an enrichment thing after school? I don't know, it's hard to tell, but those kind of shots I think those are golden.
Okay.
Because it really shows.
We can infuse that into every careers class
Yeah.
if you want
This
to.
would definitely be a component
I'm
of whatever
all about
happens,
it.
Sure.
Because Todd's got a massive bench space,
Bring
and I'm just imagining they're going to have radios laid out, and they're going to be talking from one end of the room to the other end and testing
bring
all those
in-
components in
bring
the
in
class.
business.
I will say quickly, because we did talk about 6105, and like Jeff said, that can't be the class though, because even though I lived that process, it's not very engaging,
And-
especially if it's a middle school.
NASA engineers, we kind of glass over when
We
you
do,
start talking 65.
exactly. I mean, you think thermal gets ignored. That can definitely help you, but you've got to have some hands-on stuff.
Did you not catch that today? I mean, you have these kids, I mean, obviously, when you're talking to
Yeah,
and power,
Yeah.
they really into it.
yeah.
And I mean, I tell you, these kids are, I mean, they're all different. You know, some of them are big into sports, some of them, you know what I'm saying? I mean, there's a very wide group that's in this, in all these groups that you saw, very
Right.
wide, spread within the school. And to see them all focused on this and really want to learn, that's a big deal.
And when in the end, it's going to take the diversity of those kids, their
Yes.
skills, their aptitudes, their interests, whatever, to put this thing together. You've got the folks that are conceptualizing on the experiment. You've got the folks that are tinkering in the lab with circuit board. Whatever. It's going to take all of that to ultimately put that together. So if you find a way that all the kids can do, they can try it all, but they can end up really helping out in a few places that they just shine.
It might be ideal, because the same thing here at work. You got to have a lot of different people to make any project successful. If you can somehow give people a flavor of a little bit of everything, and then maybe in the upper level classes have them choose that I want to help develop the requirements they have to go meet, or I want to go help take the hardware, and kind of let them gravitate to the area that interests them the most, that might make it even more valuable to them.
Because we felt like, this year was really about just background knowledge.
Yeah.
Trying to figure out the whole big picture. So we have some history and some idea behind what we're about to do. That's what this year was all about. They did a good job.
I think they did a great job.
So, that's a lot of stuff for any of us.
Yeah.
For me even to look at that stuff and kind of make sense of it. So, Oak Ridge guys, do you all have anything for the Huntsville crew yet? We're about to run out of time.
I just want to say thank you again. I mean, it's just such a treat for all of us to come out here, and we're just so appreciative that you would take the time and share your love of learning and space and all of that with the kids, because I mean they're so energized and excited, and not only could they be potential NASA employees, but in whatever they do. And so just thank you very much. It means a lot to them and to all of us.
Well, it's energizing to us.
It is,
To,
absolutely.
to meet you guys, to meet the kids. It just, this whole conversation, just getting all psyched up.
See, that's
Come out
exactly what I
anytime.
want to hear.
Come out
We wanted to
anytime. Come
in here.
visit.
Well, actually, my mom's in Knoxville. I'm not an
There you
over.
go.
We
See,
will
for you to
take
say
care
that
of
Come on.
means
That's right.
everything to me, because that's what I wanted to hear. I wanted y'all to walk over, hey, y'all are there. You're not there. You're on the right track,
Right.
you're moving forward, and you're doing what you should be doing. My greatest fear was we'd walk in here and it would be like, oh, we didn't do, you see what I'm saying?
Yep.
As an educator, to hear you excited makes me feel like $1 million right now. So,
Well, for somebody who sat in here last year at this time and heard the feedback and watched the kids, and then I get these little dip tests, but you see them every day. It's kind of like watching a plant grow, so you don't get to see the kind of major jump
It's amazing.
that they had from last year, and the feedback that they got here to now is
but we learned
it
from
is
what we were told
Absolutely.
substantial.
Absolutely. It's amazing.
Mhm. Yes,
And last year was amazing.
it was.
So this is even more amazing.
But I am going to go back and say that it would have probably been the same thing as last year without
This feedback.
Angie and Peter.
Yeah.
Oh, absolutely.
Yeah.
And
Yeah.
Michelle and everybody and Jerry. I mean, I'm thinking of everybody that's has kind of come along and given us different pointers, because we just know what we know at school, and when people like you all come in and give us pointers, we never thought of that. So it's amazing to see how this is all coming together, working.
It's a real boost for our school system, so I'm going to tell everyone, yes, I spent Friday collaborating with NASA engineers.
That's
right. That's
So, anyway, thank you all so much for your
Well, I
time.
hope that this is not how did you put it a minute ago? A once in a lifetime thing? Hopefully this is the first of many.
Yes.
Maybe no.
Well, that's the plan. Would you come back and listen
Sure, man.
next year?
Sure, man.
Are you in?
Well, I tried to be in last year, but I had some other stuff.
Well, that's because you're thermal, I mean.
Well,
We'll call your
I get
mom.
that, so.
What we can do
Get
is, you guys had a lot of
encouragements.
questions that some of the folks here couldn't answer. We can get the right people and we can have some FaceTime or telecons. If you guys
Yeah,
want,
one of
if
the-
that's something that would be helpful on the, was it
Great.
telemetry, some of the sensors?
GNC.
Yes. So we will arrange that and we can figure out a way to make that happen.
And if we could maybe also tap into some resources here to bring people onto our merit review and
Absolutely.
feasibility review panels, that would really be helpful. We've got other ideas as well, but we would definitely love that.
Yes, that's something that NASA is very interested in, is participating in that.
Great.
In fact, it is.
We weren't sure if that was allowable to bring in NASA
It is.
on that. Excellent.
It's part of. I know it's part of my team's performance plan is STEM activities, and NASA gives every civil servant employee 8 hours off to support STEM activities.
Yeah, the only question is,